Welcome to another deep dive, everybody. This time, we're going deep into the world of zirconium.
Zirconium.
We've got excerpts from all over the place, chemistry websites, Wikipedia, you name it,
Yeah,
all about zircon the mineral and zirconium the element.
sounds good.
So we're going to go from gemstones to nuclear reactors.
All right, let's do it.
So it's going to be a wild ride.
I think what I find interesting is how this one element, we're talking billions of years,
Okay.
literally from the stars to the sand on the beach.
Right.
And it's been kind of intertwined with human history for just as long.
Okay, let's unpack that. So you've probably heard of zircon. Maybe you've even seen one. It's a gemstone. It's been around for centuries.
Mm-hmm.
And I mean centuries, like we're talking biblical text mentions here.
That's right. I mean, the name itself comes from the Persian word zargun, which means gold-hued.
Ah,
And you'll see why when we get to appearance.
okay.
Because some of the most sought-after zircon gemstones have this beautiful golden yellow color.
Oh, so like carrying around a tiny piece of sunshine.
Exactly.
But here's where I think things get really cool. Zircon have what's called a high refractive index.
Yeah.
Now that sounds very complicated,
Mm-hmm.
but all it means is it bends light in a way that makes it super sparkly,
Yeah,
almost like a diamond.
it is. And speaking of diamonds, zircon also has a high specific gravity. So have you ever, picked up a rock and you're like, whoa,
Yeah.
this is a lot heavier than I thought it would be for its size?
Yeah.
That's specific gravity,
Okay.
and zircon's got it.
So it's got the sparkle and it's got like heft to it.
It does.
Nice. You know, while I was prepping for this, I learned that yellow-red zircons are sometimes called hyacinths.
Oh, yeah.
Apparently that name comes from the hyacinth flower, and it's even got ties to Greek mythology.
Oh, yeah, the myth of Hyacinthus. He was a beautiful youth who tragically was accidentally killed by the god Apollo.
Oh, no.
And from his blood sprang a flower, the hyacinth. And you can see why those deep red-orange zircons might remind people of that flower.
It's like this beautiful gem with this whole layer of history and storytelling just baked right in.
Mm-hmm.
And speaking of color, you can actually find zircons in a whole rainbow of shades.
That's right.
From blue and green to brown, even some that are completely colorless.
Yeah.
But here's something I didn't know. Sunlight can actually make some zircons fade.
It's true.
Isn't that weird for a gemstone?
It is unusual, but what's even more fascinating is that it's not always permanent. Heat treatment can often restore a zircon's original color.
Wow.
Almost like magic.
Okay, so it's a color-changing gemstone.
Mm.
That's pretty cool. And then there's cambolite, which is just a fancy trade name for the blue zircon you find in Cambodia.
Right.
Doesn't that just sound exotic?
It does. And it reminds us that these gemstones come from all over the world.
Yeah.
Cambodia, Australia, Sri Lanka, each with its own unique geological story.
Now, we've talked about sparkle, we've talked about color, but get this, some zircons, especially ones from Sri Lanka, are what's called weakly, or not at all birefringent.
Right.
Basically, that means when light passes through them, you don't see that doubling effect that you get with most other gemstones.
Yeah.
It's one of those little things that makes each gemstone unique.
It is, and it's actually an important detail for gemologists because they use birefringence to tell the difference between zircons and diamonds and other gemstones.
That there's more to these pretty stones than meets the eye. But you know what? There's a whole other side to this element beyond just gemstones.
Definitely.
Zirconium itself, the metal, has its own fascinating story to tell, just as compelling as the gemstones.
Absolutely. To understand zirconium as an element, we kind of have to go back to 1789.
Okay.
A German chemist, Martin Heinrich Klaproth, he managed to separate it from zircon, revealing this silvery white, lustrous metal.
Okay.
And one of its standout properties is its resistance to corrosion.
Oh, wow. So while humans have been admiring zircon sparkle for ages,
Yeah.
the metal itself only really came onto the scene a couple of centuries ago.
Yeah.
And that resistance to corrosion, that's a big deal.
Huge.
That makes zirconium super useful in all sorts of industries where things need to last.
Oh, absolutely. And it's especially important in nuclear reactors.
Oh, okay.
So zirconium doesn't easily absorb neutrons, those
Right.
tiny particles that are key to nuclear reactions.
Yeah,
This, along with its ability to withstand high temperatures and, of course, that corrosion resistance,
right.
makes it ideal for reactor components.
So zirconium is like the superhero of metals in the nuclear world.
You could say that.
You mentioned specific alloys called zircaloys. What are those?
So zircaloys are basically just zirconium,
Yeah.
with tiny amounts of other elements mixed in, things like tin, iron, chromium.
Okay.
Adding these creates an alloy that's even more resistant to corrosion than pure zirconium, which is perfect for the really intense conditions inside a nuclear reactor core. So you can think of them as the cladding that goes around the uranium fuel rods,
Okay.
keeping everything safe and contained.
It's amazing how this element went from being known for its beauty to being a key player in one of the most powerful technologies we have.
Yeah.
And this whole nuclear chapter in its story only really started in the late 1940s.
Relatively recent.
Yeah, it seems pretty recent given how long we've been talking about.
Yes, and getting it ready for those nuclear applications wasn't easy.
Uh-huh.
The challenge was separating zirconium from hafnium.
Okay.
Hafnium is another element found alongside zirconium in nature, and they're so similar chemically.
Okay.
But here's the catch. Hafnium loves to absorb those neutrons,
Oh.
which makes it terrible for nuclear reactors.
So it's like trying to separate two peas in a pod.
Yeah.
But these peas have completely different personalities when it comes to nuclear energy.
They do.
So figuring out how to purify zirconium and get rid of that hafnium was essential for unlocking its potential in the nuclear world.
Exactly. It was a real turning point. Once scientists figured out how to separate them efficiently, we could finally produce high-purity zirconium and open the door to using it in nuclear reactors all over the world.
Okay, so we've gone from ancient gemstones to the heart of nuclear reactors.
We have.
And the story just keeps getting more interesting. But it doesn't stop there. Zirconium has even more fascinating uses, some of them completely unexpected.
Like the fact that if you alloy it with niobium, it becomes what's called superconducting at extremely low temperatures. This means it can conduct electricity with absolutely no resistance.
What?
Zero. That's a huge deal for certain technologies.
So zirconium just keeps getting more impressive? And then there's this one that blew my mind, zirconium tungstate.
Yeah.
This stuff actually shrinks when you heat it up.
I know.
That just seems backwards from how most materials work.
Right. Most things expand when they get hotter. But zirconium tungstate does the opposite.
Wow.
It's what we call negative thermal expansion, and it makes it really useful when you need very precise control over how materials change with temperature.
It's like zirconium loves to keep us on our toes with its unexpected abilities. It's clear that it's way more than just a pretty face or a workhorse in nuclear reactors.
Definitely.
It's got all these hidden talents just waiting to be discovered.
And speaking of hidden talents, let's zoom out a little
Okay.
and look at zirconium's presence beyond Earth. Believe it or not, it's found in S-type stars, and it's actually more abundant there than it is here on our planet.
So it's like a bit of a cosmic celebrity.
It is.
And it's even had a guest appearance on the moon, right? I remember reading that the lunar rocks brought back by the Apollo missions had higher concentrations of zirconium than the rocks we find here on Earth.
That's right. And this difference in zirconium levels between lunar and terrestrial rocks is something scientists are still studying. It gives us clues about how both the moon and Earth formed and evolved over time. But back here on Earth, zirconium's story takes us on a journey through time, starting with its presence in zircon, a mineral found in various types of igneous rocks. You can find it all over the place, from deep inside the Earth to scattered on beaches.
So it's like a time traveler carrying secrets of Earth's ancient past.
It is, and zircon's incredible durability is a key part of this. It's tough enough to withstand weathering and erosion,
Right.
so it can hang out in sands and sediments for literally billions of years.
Wow.
That means it preserves information about the conditions under which it formed, giving us a glimpse into Earth's early history.
So it's like having a window into deep time. And speaking of time, didn't I read that zircon is also used in geochronology, the science of dating rocks?
You did. By analyzing the decay of radioactive isotopes within zircon crystals, scientists can determine the age of rocks with incredible precision. It's completely revolutionized our understanding of Earth's history. Now we can piece together events that happened billions of years ago, all thanks to zircon.
It's like having a geological clock. What about Australia? They seem to be like the big players in the zircon world. I read that they're responsible for a whopping 37% of global zircon mining.
It's true.
That's a huge chunk of the market.
Australia has vast reserves of zircon-rich sands, making them a major force in the global zircon market. And some of the most significant discoveries in zircon-based geochronology have happened there too.
Like the discovery of those 4.4 billion-year-old zircons,
Right.
the ones found in Western Australia.
Exactly.
Those are considered the oldest known minerals on Earth. It's pretty mind-blowing to think about holding a mineral that's been around for almost as long as the Earth itself.
I know. Those ancient zircons are like time capsules, giving us invaluable insights into what the early Earth was like. They've helped us push back the timeline for the formation of continents and the presence of liquid water,
Okay.
painting a much clearer picture of our planet's early days.
So not only are these zircons incredibly old, but they also provided evidence that liquid water was around much earlier than we previously thought.
Yeah.
Which has huge implications for understanding when and how life might have first appeared on our planet.
That was a game-changing discovery.
Yeah.
Imagine, the Earth was thought to be this hot, molten inferno back then. But the chemical signatures within these ancient zircons revealed something different. They pointed to liquid water interacting with rocks, challenging everything we thought we knew about the early Earth,
Wow.
and opening up new avenues of research into the origins of life itself.
It's like we're rewriting the first chapter of Earth's story. So we've covered a lot of ground here. We've talked about zircon's ancient sparkle as a gemstone, its crucial role in modern technology, and its ability to unlock secrets from Earth's distant past.
It's been quite a journey.
It has.
And while we've explored so many fascinating aspects of zirconium,
Right.
there's always more to learn.
Yeah.
We've seen its versatility, its resilience, its hidden talents. But is it possible there are still undiscovered uses and benefits waiting to be uncovered? It makes you wonder what the future holds for this incredible element.
It really does make you wonder.
Yeah.
It really does make you wonder. Okay, we've been through a whirlwind of zircon and zirconium facts, from ancient history to high-tech applications. Before we jump ahead to the future,
Yeah.
let's take a minute to recap what we've learned about this amazing element.
Yeah, you're right. It's easy to get lost in all the details.
Yeah.
So big picture, what stands out to you about zirconium?
Well, I think the biggest takeaway for me is that zirconium is so much more than meets the eye.
Right.
We started with these beautiful gemstones,
Yeah.
but then we uncovered this whole other side to it.
Mm-hmm.
This powerful, versatile metal that's literally shaping our world.
Exactly. It's not just a pretty face, it's a real powerhouse.
Yeah.
And I think that versatility comes from its unique combination of properties.
Yeah, we talked about its hardness, its durability, how it's
Uh-huh.
chemically stable, and of course, that incredible resistance to corrosion.
Yeah.
It's like it can handle anything we throw at it.
Pretty much. And then there's that amazing nuclear characteristic. Its low neutron absorption cross-section.
Right.
That one property alone has made it indispensable
Yeah.
in nuclear reactors all over the planet.
Oh, and let's not forget about those quirky, unexpected things we learned,
Right.
like how some zircons can change color,
Yeah.
and how zirconium and tungstate actually shrinks when you heat it up.
I know, it's crazy.
It's like this element is full of surprises.
Those little quirks are what make exploring the world of elements so fascinating,
Yeah.
isn't it? There's always something new to discover, some unexpected twist that changes how we see things.
You know, one of the things that really captivated me was how deeply connected zirconium is to the history of our planet.
Uh-huh.
Those ancient zircons, the ones from Western Australia that are billions of years old,
Right.
they're like time capsules, giving us a glimpse into Earth's infancy.
It's incredible how much information is locked away in those tiny crystals.
Yeah.
We learn that they provided evidence of liquid water existing way earlier than we thought,
Right.
which has huge implications for our understanding of when conditions suitable for life might have first arisen on Earth.
It's a good reminder that the elements around us aren't just building blocks of matter.
Yeah.
They're storytellers,
Mm-hmm.
carrying within them the narrative of our planet's evolution.
It's a beautiful way to put it.
And those ancient zircons, they're telling us a story that's billions of years in the making.
And that story is still unfolding as we continue to delve deeper into the mysteries of the elements. You know, all of this might seem like pretty technical stuff,
Right.
but it actually relates to you, our listener,
Oh, yeah.
in some pretty interesting ways. You might
Okay.
be thinking, okay, that's all very cool, but why should I care about zirconium?
Yeah, exactly.
Well, aside from the fact that it's just plain fascinating, understanding this element gives us a glimpse into how interconnected our world really is.
Yeah.
It shows how something can be both beautiful and practical,
Uh-huh.
both ancient and modern, both
Right.
earthly and cosmic.
I like that.
And it's a reminder that there's always more to learn, always more to explore, even in the things we think we know well.
Yeah.
Like, did you know that zirconium is actually in a lot of everyday products?
Wait, really? Like what?
Well, it's in some deodorants.
Huh.
It's used in water purification systems.
Oh, wow.
And it's even used in some types of ceramic knives because it's so hard and durable.
Wow, I had no idea. So even though zirconium might not be a household name,
Yeah,
it's quietly working behind the scenes, making our lives better in all sorts of ways.
exactly. It's one of those unsung heroes of the periodic table.
So I guess what we're trying to say is
Yeah.
next time you see a sparkling zircon gemstone,
Mm,
or you hear about new developments in nuclear energy,
right.
or even when you're just going about your day-to-day life, remember the story of zirconium?
It's an element that truly embodies the wonder and complexity of the world around us.
I agree.
And it shows us that even in the smallest things, there's a universe of discovery waiting to be explored.
It's amazing to think about all the places we find zirconium. From stars to sand,
Right.
from ancient gemstones to cutting-edge technology, and
It really is.
who knows what the future holds. Maybe it'll be at the forefront of some groundbreaking new invention.
Yeah.
Or maybe it'll help us unlock even more secrets about the universe.
The possibilities are pretty much endless. I mean, we've already seen how its unique properties have led to innovations in so many fields: nuclear energy, aerospace, even medicine.
It's like zirconium is constantly reinventing itself,
Oh,
finding new ways to contribute to human progress.
it is.
And as we keep exploring and learning about the world around us,
Yeah.
I have a feeling zirconium will have many more stories to tell.
I think that's a great point. It reminds us that even in something as seemingly simple as an element,
Right.
there's a whole universe of complexity and wonder just waiting to be discovered, and that's what makes science so exciting, isn't it?
Absolutely. It's all about constantly questioning, exploring, and pushing the boundaries of what we know.
Definitely.
Who knows? Maybe one of our listeners out there will be inspired to make the next big zirconium discovery.
That's the beauty of knowledge. It has the power to spark curiosity and inspire innovation. So to all our listeners out there, we encourage you to keep learning, keep exploring, and keep that sense of wonder alive.
Because you never know what amazing discoveries are waiting just around the corner, hidden within the elements that make up our world. Thanks for joining us on this deep dive into the world of zirconium.
Until next time, keep asking those big questions and never stop exploring the fascinating world of science.